All right, welcome to another coding session. Back with Bangalang. Maybe I should give an overview. I used to do that quite often when we first got started, but I haven't done it in ages. So we're creating a language here, which I usually say that it's a low-level, explicit, compiled, procedural language. So we're compiling directly to assembly. It's low level, so there's not a lot of abstraction going on. Kind of what you see is what you get. So the code fairly directly maps to assembly. And we don't have object-oriented or anything like that. I like things simple. Procedures are simple. Objects are not. So I don't have them. And then the kind of main goal that we had was to easily run something on the GPU and then on the CPU. So we do have, and this is what the code looks like. This is source code in my language. Mostly it's setting up a whole lot of OpenGL stuff. This here is setting up an OpenGL buffer and mapping it to a pointer that we can get access to, this buffer data pointer. Bunch more stuff. So this is where it starts getting interesting. We have this task func and task func GLSL. So they are both, like this is used on the CPU, this is used on the GPU for basically doing the same thing. They move these triangles. These guys here, they get moved using just by adding a delta. And there's a whole bunch more boilerplate. But right now, this is the guts of it. This is what's doing that work. It's doing it on the GPU right now. So if we comment this out and we uncomment this, this is how we do it on the CPU. So that goes a bit slower. And the idea is that it should be very easy to, like, we should be able to use this Boomstick to do the GPU and CPU, so we can get rid of this boilerplate code. This here is compiling this here. This here, because it's marked as GLSL, will get compiled. This is the assembly. It gets compiled here, so this is the output. It's an OpenGL compute shader that basically does the equivalent of this. And this here is compiling that into an OpenGL program, which we then use and execute, basically. And this is binding the parameter. So that's where we're at now. The idea is to be able to do that very seamlessly. So this here I consider boilerplate that we want to get rid of. This should happen in the background. Instead of doing something specific here, we should be able to just call Boomstick and it should just work. What else? Up here, when we create the buffer, is terrible. It should be just this. The reason we had to do this is because we needed the name. So this is the part I want to tackle first. Let's see if we can get rid of all this boilerplate so we can just have this again. Now, in order to do that, so actually let's just cut it out. We want to have this work. And the reason it doesn't work is because if we try to run that, if we try to run that, it does work. Probably because we're running on the CPU, are we? We are. If we try to run on the GPU, when it tries to bind that parameter, it should give us an error. Yeah, buffer name is not defined. So we need to get that name somehow. So this here is being allocated using the VRAM allocator. So let's open that up. It's in our standard library core memory. And let's have a look at what we can do here. This is the VRAM allocator. So this is very similar to the code that we had just seen here, you know, this kind of code. And this is the buffer name. So basically we want to save that buffer name somewhere. We kind of want to have a map because this is returning a pointer. So we kind of want to have a map of these pointers to their corresponding names. Currently in this language, we don't have a map. I would like to implement a map at some point, but we don't at the moment. So I'm just going to use a couple of arrays, and the corresponding things will be at the same index. So if I say VRAM Allocator names, and the names are i32s. So let's just say we have 100 i32s. And addresses, let's put it up here. And what we need to also have is a count. I'll make that an i32 as well. So we're kind of reserving space for 100 of these. So if we, this is just a temporary measure. So right now, this is how we're doing our map. So we only have space to do 100. When we have this count is telling us how many we've actually put in here so far. Like right now, these are uninitialized, they have nothing in them. So what do we want to do? I think I'm going to move this down here, separate this stuff out a bit. So we generate this buffer with this buffer name. And this is kind of a quirk that we have to bind it to something before this works. So what we can do is we can say the names at here, so that's the current, the index of the next available spot in our array, equals, I'm just going to say name, equals the name. So now we've saved the name. This is getting us the address. So now we want to save the address. So we'll get the addresses, save that there. And then we need to say, okay, we've added this and return the address. Ooh, excuse me. So hopefully that makes sense. We generate a buffer. We save the name of that buffer in one of the arrays. Then we acquire a pointer to that buffer so that we can manipulate it easily, the data easily. And we put that address in the other array. And then we say, okay, next time we come in here, we need to do it on a different, we need to do it in the next place in the array. And we return the addresses, which is what we normally do. Now, what is the problem here? The way my language works is that these are allocated on the stack. This is a procedure. Within a procedure, you do not have access to these. The main reason being we don't know where this is going to be called, and stack addresses are relative, meaning that within the context of this procedure, it does not know where these are. It can't know where they are. So to get around that, what we need to do is make these, oh, I've done it again. We need to make them static. No, we need to make them static, which means they will be stored down here. The problem with this is that right now our static variables are very limited on what they can hold. They can only hold integers right now. They can't hold arrays. So I want to try and remove that limitation. I did think of an easy way to do it. So we need to go into type checking. Where do we need to go? I think it's assignment. Yeah. So this is where we're type checking an assignment. The assignment uses an allocator, and if the allocator is static, here's where we restrict it. You know, we say you can't allocate non-integer types. You must explicitly assign an integer literal. We want to get rid of that. No restrictions. And the way I'm going to do that is I'm going to change a bit the way that they're initialized. See, right here we can see some static variables that are initialized with their initial value. So if we go to this file where they're declared, this is where they're declared. So we just straight up putting into the executable those initial values that we assign here. Instead of that, what I'm going to do is I'm just going to assign everything 0, initialize it, because that's what our language does with all variables. And then when we get to this line of code, then we assign it to this number, just like we normally would. So it happens at runtime. And because it happens at runtime, we're no longer restricted to what we can put on the right-hand side. We could put anything. Anything that we could use on like a stack variable, for example, we could use on a static one now. So we need to go to our generation. I think that's when we generate the program. Yeah, everything's in the right place. You can see I've been looking at this stuff already. So this is where we initialize it to, so the right-hand side is the value of the number, the defined size. Why do you do that sometimes, Light? The defined size is like, you know, DD in this case, which is double, so that's 4 bytes, so 32-bit integer. So we want this to be not so restrictive. I think I also want to make it so that it uses the static vars. Did we do that up here? We do, up here. So I might just actually cut that out, bring it down to here. And we need to do something, I mean, like most of the time we just want to initialize it to 0. But there is a special case here. What was this? This is a GLSL variable, right? The only thing I've put in here so far are the GLSL, like this guy here. So this guy needs to be a string. At the moment I made it a C string, you know, null terminated, but I think it would be better if it was one of our strings like this. So I think I'll take this opportunity to change that. But so they need to be treated specially because they do need to have an initial value, whereas these don't. So I think the way is to say like if, and what is the static var at the moment? I think we want to make it the assignment node. I don't know if that's what it is. How do I get down there? Static var dot, yeah, I don't know what it is right now. It's not letting me jump around. It's a map of string to strings. So I think I want to make that an AST node. So then I can say, well, we need the left-hand side node. var node children 0. And if the allocator of that is GLSL, then we need to do this special thing. Otherwise, we just want to 0 initialize, which I guess is something similar to this. So that's the name of the variable. I did look up how to do this. You can do this. So this is the name. Then we go times some number, do a 0 byte. And that will result in that number of bytes all initialized to 0, which is what we want, where this is the size of the variable. So that's like a percent %i, and we can take those out. So it's not a defined size, it's just the size. I don't know why of type string has no filled children. Didn't I? Because we need, okay. So is that static var name is the key? I guess it is. So that's the static var node. Is that how it is? That's the name? I guess that makes sense to me. Although it's, now that we're taking like this node here, it's like the whole assignment node, the left-hand side value is the name. So I'm starting to think like, what's the point in having this on map? Maybe it should just be a dynamic array. Let's see. So we have the left-hand side node, 0 initialize. Here we want to do a string, not a C string. So let's have a look at that. I also thought that we could refine this a little bit, because I think we can just put this here. Well, I'm kind of wondering if that works. And I would also like to do $raw, because underscore data could potentially be the name of another variable. But if we put a $sign in, which is valid in these label names, but not valid in identifiers, that means there could not possibly be a collision. So I wonder if that will work. We can't test it right now. That was a bit of a gamble doing that. But I think something like that should work. And then down here we can do the same thing, but instead of string literal, in the case of this, we know that well, instead of index, I guess we have that should be $raw. We need the name, right? So it's like %s and %s $raw. And that's the final string. Although in this case, I don't think it's going to have quotes around it. So I think we need to add the quotes. What's this index? We've got %s, 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 so I think that should be the name as well. And this should be the value, which is like the right hand side. Is that right? What am I talking about here even? Final string. Yeah, if we passed in an assignment where the right hand side is the string, I think that's right. So up here, we're going to need to construct basically an assignment, the AST for an assignment. And then when we get down here, it should work. And everything else we just initialize to 0, and we ignore the right-hand side because that will happen at runtime. This is compile time stuff. I think that's about right. Yeah, so here we need to create the static var node, which is an assignment node. Then we want the children, we want to add what would it be? An identifier on the left-hand side where the value is the name of the procedure. Then there is an assign node, so that's the equals. And then the third child is the right-hand side, which will be a string. And its value, well, I guess if we really want to model how this should be, this should include the quotes here. Like normally, a string like this would be wrapped in quotes, because I was just going to put this. And maybe I still will. So then that node goes there. So we want to have the correct allocator set as well, because that's how we determine that we want to do this. That's how we determine, where was it, further down, that we want to do the special handling and make a string. And we also probably should give it a type on the left-hand side. We have left-hand side node, we don't have the type node yet. So let's get the type from left-hand side, like so. I think that's more or less an assignment AST. Left-hand side equals right-hand side. Procedure name, procedure code. Yeah, we didn't add a type node to this one, which we could, but I mean, I'm not even sure that this type matters. We're not actually even using it. Maybe just to keep things simple, I'll get rid of that, because it's just this GLSL that we need. But I don't think we use the type. And then that, okay, I think there's probably going to be some code that's not happy. Auto dereference, index, assignment left-hand side is an index. What is it indexing into? VRAM allocated names. Okay. So that seems unhappy. Interesting. And it's auto dereferencing. Ah, but there's no type. I'm not sure why there would be no type. Statement, assignment, and then there's like going into a scope, and where is this actually? Okay, yeah, it's inside. Where's our memory? It's inside here. So another thing is that, although that I'm not happy with this error that's happened, it should really have just said, hey, like, this is not accessible, because static variables are not accessible inside here yet. That's something I need to change and I had forgotten about. So let's see if we can do that. That's the context, right? I guess it's the type checking context. Yeah, when you copy, there's like, when you're going into a sub procedure, we're going into a procedure, it's not considered in line. So only types, modules, and procedures are the current things that could go from here to here. Static variables don't count. And actually, not all procedures should go down. Like if it's a stack-based procedure, it should not go down. So I think what we actually want to say is if the allocator is static or if it's GLSL. I don't like putting GLSL here because I don't like GLSL to be the special thing. I kind of want to have a bit more of a generic solution at some point. But that should make the static variable accessible within the thing. Buffer name is not defined. Pointer to I8 and I32 are not compatible. Yeah, that should be a pointer to I8. Pointer to I8 and I8 are not compatible. You know what I think is happening? I think the precedence of these operators is not working in my favor. Because if we go back to here, see, this is the same, you know, it's a pointer to this thing, an array of that thing, which means it's a pointer to this. Not that it's an array of these. It's an array of these that we have a pointer to. So I think to differentiate, we need something like this to say, no, look, this is an array of pointers. And that's going to throw a fit right now. You're not allowed to do that. So let's relax our parsing a bit so that we can do that. Primary. Yeah, of course it's primary. I'm used to there being multiple. So if we have an opening bracket, yeah, I've said right-hand side primary can have, only a right-hand side primary can do it. I think anywhere we can do it, right? Left-hand side types. Here it's a right-hand side expression. Let's bring out the old grammar array. We haven't brought out the grammar for a while. So for a right-hand side primary, there is, here it is. In brackets, you can have a right-hand side expression. But I think for like a type primary, in brackets, we want another type primary. I think that's basically what we want. And same with the left-hand side primary. I feel like it would also be the same. You don't want another whole left-hand side expression. Left-hand side primary. Yeah, okay. So maybe we'll update the grammar a little bit. We don't do that very often these days. This looks like it. So I think we put it like there, but we're going to say a type primary goes in the brackets. And for left-hand side primary, put it there, and it's a left-hand side primary that goes in the brackets. There we go. Okay, and in parsing, I think we say if type equals right-hand side. So that's the type of primary that we're parsing. If we're parsing a right-hand side primary, we do this. Otherwise, we recurse and say parse primary, and we pass in that type. Okay, I think that should be it. So hopefully that will fix that up. Buffer name not defined. It really doesn't want to be defined. Okay, so that's the one that we expected to not be defined. Down here somewhere. Here he is, 113. So here, what I'm going to do is I'm going to import. We already have memory imported. So memory dot, just as a bit of a hack to get this working, I'm going to say VRAM allocated names. Where were we? Example. And I'll just get the first one because that should be it. We're only doing one VRAM allocation, so that should be the correct name. So, okay. I guess we can see what happens. Failed to generate assignment. I just remembered one part that we haven't accounted for yet. And I think this is it. This is it. So this is when we generate an assignment and we've established that this is a new variable and we do different things based on different allocators. So now we need to say, hey, what do we do if it's a static variable? And what we need to do is add it to the static vars. So we can add this whole assignment node to the static vars. Oh, but yeah, with the name, but do we ever, let's have another look at that because, where is it? I feel like we never used the name. Here. We only use it as a key, right? Like what's the point? We only use it to get the thing back. So let's just make it an array. I think we just make it an array. Like that. So now up here, we need to use append go to our assignment, we also need to use append. It'll also mean that the order is deterministic. The ordering of these static vars in the output assembly will always be the same, which is kind of nice for comparisons. If you want to compare assembly before you did a change and assembly after you did a change, it's helpful if the changes are minimized. It's a nice thing for debugging. So now down here, static vars now is an array. So I don't think we use the index either, do we? So that's static var node. Like so. So now that we're putting, where was it not type checking? Could probably get rid of a bunch of these. That's the parsing one. Looks like we didn't change these. Was it generating an assignment? Yeah, now that we have put all of the static vars into our list, they should all end up like this. Let's see. Oh, this is the old code, which we replaced. We don't need that anymore. Okay, it's not happy, but we got some output. Oh, okay. I can see immediately what one of the issues is. This is our new string format. This is one string. So this is the raw bytes. And then this here is the actual string. So it's a pointer to the raw bytes, followed by, this is the length. $sign is the address of this. And this is the address of this. So when you subtract them, you get the length of this. That's the idea. So the strings are a bit more compact. This has a raw and also one, so that's proper string. But the new lines are not handled properly. That's why it's not happy. It's like an escaped new line. Maybe if we don't escape. Okay, that looks better. That looks better, but now we have more issues. These are not being defined. Why the hell not? That's including our new ones. So I do think in AST there's this guy. So I'm kind of wondering, what do we do with him? So when we're generating statements, we skip them, which was correct before because we initialized them correctly in here, but now we want to initialize them as 0 in here, which we're not doing actually. Probably also because we don't process them. Probably also because we don't process them here. So actually this is the only place it's used. Maybe I can just cut it out. This needs to be, we still don't want static procedures to be processed as statements, but other static assignments we do. Okay, look at this. This is getting much better. Yeah, look. So they're all getting 0 initialized. Up the top here, I feel like up the top we should see their initial assignments, so we need to work on that. But we still have, this is redefined. 2068. Originally defined at 2052. Oh, interesting. Why? Why would VRAM Allocator count? So this is the assembly. Okay. This is where it's actually defined. And then it's just used, right? Why would that be? Here it's on the left-hand side of an assignment. It's an identifier, it's not a member. And it's not on there. I guess a map would have avoided that problem. But we do put it in here anyway. We do put it in here anyway, which should mean that this should trigger. I mean, it should prevent us from going in here twice. Although, no, we have a new context because we're in the procedure. So that's never going to prevent it. So what we do now, I think, because it's an identifier, it's not a member. But it could be defined already. So let's just say static var found. I feel like it's like I can never remember which order these return values are in. So let's do a linear search through the existing static vars for our static var. But it's not as simple because that's a node. Whew. This is a pain. Okay, what to do? So let's get left-hand side. Left-hand side. It's not that we want to return or anything. We just want to not do this. So what am I comparing it with? This guy. Oh. There we go. And then we just say if not found, then we add it. Jeez. Let's try that. Okay, this is like compute shader stuff. Look at that. Got all of our assignments. I'm a little bit worried about this. These empty assignments at the top. Another thing that comes to mind is the ordering of this stuff. But let's have a look down here. So this is our GSL function. So we've changed this to a string, but our code that's grabbing it is not treating it like a string. Here it's treating it like a C string. So we need to do that. That's nice. We can just put length there now. Untype that as well. Maybe that handles that better. Length is 64-bit, but we want 32. Oh, wow. That kind of wasn't expecting that to work. Huh. Where did our empty assignments go? I kind of want to scroll down to the bottom. Here they are. I don't know what those are about. Well, I guess they could be. Could they be these assignments? Because there's nothing to assign? I mean, they should be nullifying, right? Shouldn't they? Oh, if allocator is stack. Nullify. I think we want to nullify static as well, right? Ooh. Well, that broke it. So here it looks like we're nullifying, which is a good thing. Oh, but where did our initial assignments go? They disappeared. Oh, we're in procedures now. We're in procedure town. Where's our print? Extern, right. We're in procedures. We're in procedures. Check on OpenGL error. Extern. Default exit. That's what I should find. Okay. So here's our nullify. Oh, and here's our. But it's right at the end, man. It's right at the end, which is not helpful. Yeah, this is what I was thinking. I thought the order might be wrong. Because these things happen in this GL file, which is imported at the top of our program. You know? So they should happen before all this code. But they're not. They're happening after. So we need to review our ordering of generate statements. Yeah. So right now it just loops through all the modules in a map, which means that the order is not deterministic. That's what I was just talking about earlier. So instead, we probably need to do something more like what we do here. You know, where we go through and we use the references. And we need to keep track of what we've generated already. I guess it's import names. So I guess we want to do like the current module. So we probably need to pass in a module name. Right, so instead of looping through, we process that module. But before we do that, we need to loop through any references to other modules. So I guess we need to get this first. Well, procedures. No. We need to get the module. And go through all of its imports and call generate statements on the import. So the module name will actually be the result of like the value in this map. Need to pass that through. But before we do anything, we first need to check, like we do here, whether it's already been done. Found generated module. So we look through the names for the module name, and if we found it, there's nothing to do. And if we didn't find it, then we add it, and then we do stuff. But we need to generate the imports first and then last this thing. So in the case we were talking about before, we generate the GL import before doing the main one. I think that should fix the ordering. Looks like we're broken here because I think it's the same as the procedure name. Is that right? Yeah, that worked. So now we should see, yeah, these are at the top, followed by these, followed by the regular code. Perfect. Okay. So that was a lot of work. Took us nearly an hour because we did do a lot of changes to our static variables, that's why. But the result is that instead of this, we have this again. And our next targets are this guy and this guy. And I think they're going to take a fair bit of work. So I don't think I want to tackle them right now. But one thing I was thinking to do, which shouldn't take too long, I mean, I do have a list of things in here, but the thing that I thought might be just a little easy thing to do is I wanted to separate Boomstick out from the threading file. So this is all regular threading stuff. There's Boomstick, which I'm going to call Bang now. It's in the Boomstick module. It does rely on some threading stuff, like a thread pool. Unfortunately, VEC4 is part of threading. We will fix that. We will fix that eventually. Like so many other things, it will get fixed eventually. Bang. Yeah, so we can go to threading and cut the Boomstick out now. And then when we go back to our example, we can go Boomstick, call Boomstick, Boomstick Bang. So let's cut out the GPU stuff, go back to Boomstick Bang, boom, and it works. And because I think these are nice little wins, I think that something we can do is also take this pool, this thread pool, and move it into Boomstick and say, hey, this is also static. And we initialize it. And now we don't need to pass this in. We just have it. We probably need to say it's a pointer now. And the weight can be after. Now the catch is it's probably not the most efficient way to do things, is to, like, every time we do a bang, we just wait for it to finish. So that's just a temporary thing. Also here, we just hard-coded 8. Another alternative is that we could somehow get the user to supply this, but this will do for now. So we don't need to pass this pool in. We don't even have a pool here anymore. We do use threading. Is it just for this VEC4 business? That's ridiculous. Thread pool start not defined. Interesting. So that's saying that we're trying to, we're trying to call thread pool start, which makes sense. But for some reason, it doesn't exist. What's going on here? So let's have, this should be very high on the program, this code. What the hell is all this? Maybe it's because, see, look, it's using, No, it's just setting memory. Setting some stack memory to 0. It's like nullifying a whole bunch of stuff. What's going on here? So where was my reference thing? All right, thread pool start. So we're calling it. This here, I'm not sure what the hell's going on. Ah, yeah, because, yeah. So thread pool has a whole bunch of members. This is the only one we're setting to something. So there should be a whole bunch of stuff that's getting set to null, 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 null. But there should be one thing, yeah, that's getting set to 8. Yeah. So this is the work account, and this is a bunch of other things within it. And then we're saying, hey, thread pool start. And the computer's like, what do you mean thread pool start? Also here, work account. It's like, I don't see work account. This one is, this one is worse. This should not. This is within bang. So it seems to think that that is a static or variable. So maybe what's happening here is we're looking at members of a static thing, and we're saying they also have static. Positioning, which they do, but they should be offset. Like this should be just an offset from this. This is a static thing, so it shouldn't be work account. It should be the pool plus whatever the offset for work account is. So I think we need to go to generation identifier. So for this stuff, it doesn't care whether it's a member or not. It's just saying, hey, this is me. And this is the child of this, or this is the child of this. This is the child of this in AST terms. So if I go back to wherever the hell I was, identifier, the child thing needs to happen first, which will be the actual thing that you're a member of. So this will happen first, which should do this thing. And it's not a member. But then we need to do this, which is also static, but it is a member. The child location should be the result of this. And then I think we're just offsetting it. So I think that's correct. I think we need to just like take this up here and move it down so that the member stuff takes precedence. How do you like them apples? Not very much, apparently. So it's a member of a module. So the child location is probably like, what, nothing? Oh, no. R11, really? if it's a module, do we just want to do this and just ignore the fact that it was a module? Let's just put these in order of alphabeticalness. Add a module and say do nothing and see if that works. Okay, thread pool start is still not defined. So we're getting closer. Yeah, so instead of worker, now it's saying pool. And because the worker count is the first member of pool, there's no offset. There's no like +8 or something. It doesn't need an offset. So that stuff looks right. But there's no thread pool start. So a thread pool start here in threading. Boomstick imports threading and says here's thread pool start. And why is thread pool start not being added? Because we're starting from the main procedure. Oh, there is a context of procedure name, so I should, oh no, that's what I'm using here. So that's the entry module. We should be looping through all the modules and printing out the procedures. Here, order is not a concern. I mean, like I said before, it would be nice if they were in a deterministic order, but it's not so much of a concern. So let's see. Let's just say for module name in context.program.modules. There. So then that should generate procedures from referenced by all main procedures, if that makes sense, because there's a main procedure per module. Like in Boomstick, here is the main procedure, has that code, and then this is a separate procedure. So this code was not being looked at to see what procedures it references. I think that's it. That's not good. Oh, link. Because previously we never actually looked for procedures referenced by these files, which have link in them. Now we do. So I guess we need to add link here as something not to generate. Because link is just a compile hint. Ooh, doesn't actually result in code. There we go. It's kind of slow. Probably because there was 2 of them running. There we go. Awesome. Also, I had been saying previously that I was like, I don't know why the performance is all over the place. But the fact that I'm recording, apparently that makes a big difference. So that could be a reason why. Okay, it seems like we've made a lot of progress with like stuff that I didn't realize was an issue. Like putting this code here has exposed a few things that we've now fixed. Static is so much more flexible. We can just assign anything to a static. And anything can be declared static, basically. And that has allowed us to do this in our memory, which has in turn allowed us to remove a bunch of boilerplate here. We still want to remove this boilerplate, which compiles the GLSL kernels, and this boilerplate should be hidden away inside here so that bang is all you ever have to do. Let's just do a quick test of the GPU side. There we go. Yeah, that's also quite slow. That sometimes gets up to like 8,000 or something, but today it feels like going slow. All right. It feels like, you know, all we really did was manage to get rid of this stupid code and refine this again. But behind the scenes, you know, I feel like we made quite a few improvements. So I'm pretty happy with that. And I'm really looking forward to continuing and getting rid of this. Like if we can get rid of this and this, and just make it so that we have, you know, this one function that we can take this on and off of, man, that's kind of like what I've been trying to get to all this time. I get distracted sometimes, but yeah, I'm looking forward to that. And I think in the next session, we might be able to pull that off. Okay. Thanks for stopping by. Have a good one. Ciao for now.